Hey guys, it's Miss Jackson. So in this video, we're going to be learning about tables of equivalent ratios. And our objective will be that by the end of this lesson, you'll be able to use tables to find equivalent ratios. So let's start with a warm-up. Answer the following questions as a refresher, since you will be using these skills in this lesson. If you do not know the answer or how to answer the question, or you get most of them wrong, you can watch a tutorial that I have linked for you. So try these answers, pause the video, and get back to see the answers. All right, so here are the answers. Compare these to what you got. And if you feel like you need some more support, you can go ahead and watch a video. So when we are preparing big meals, sometimes we have to expand the recipe. Recipes are often written to serve 2 to 6 people. If you are making dinner for a large family or a group of friends, then you will need to increase the number of servings. If you have a recipe that makes 2 servings and you want to make enough servings for 4 people, all you have to do is double the recipe or multiply 2 by each of the ingredients. So that was easy, right? But if you have a recipe that makes 4 servings and you want to make enough servings for 22 people, you can use equivalent ratios to find those new measurements. So, a question I have for you is, what strategies can you come up with on your own to increase your ingredient amounts go from serving 4 people to serving 22 people? So pause this video and write down what you come up with. All right, so we're going to talk about various different vocabulary words in our lesson. First, we're going to talk about model, then equivalent ratios, ratio table, scaling, and double number line. I want you to write these definitions down as you learn them. Our first vocabulary word is model, and a model is a mathematical representation of a real world scenario, and these are used to make predictions or provide insight about a situation. So you might think of a model house. Sometimes they have the really small house that has these little tiny pieces of furniture and people. Those are models compared to big houses that are super huge. So we're just going to be looking at a situation, a scenario that helps us to understand something that actually happens in real life. So our essential question is, how can you use a model to find equivalent ratios? And here is a question that we can apply that to. Elijah is making smoothies for his siblings. For one smoothie, he needs 5 strawberries and 10 blueberries. Model the amount of pieces of fruit needed for 1, 2, and 3 smoothies. So I went on ahead and laid out 5 strawberries and 10 blueberries, and this is for 1 smoothie, but we need 3. So let's go to the second one. We got 5 strawberries and 10 blueberries again, and for the third one, we have the same thing. So as you see, we were able to keep the same relationship between strawberries and blueberries, and we made it to 3 smoothies. So now we need to see how much we have in all. So 2 things we can do are add all the strawberries and blueberries or multiply. So let's start with adding. If we add all the strawberries and blueberries, we get 5 strawberries and 10 blueberries for 1 smoothie, 10 strawberries and 20 blueberries for 2 smoothies, and 15 strawberries and 30 blueberries for 3 smoothies. Okay. Or we can multiply by doing 1 smoothie times 5 strawberries, and that gives us 5 strawberries. And 1 smoothie times 10 strawberries gives us blueberries, gives us 10 blueberries. So that's the 1 smoothie. For 2 smoothies, that's where we have the second line. 2 smoothies, we have 2 smoothies times 5 strawberries per smoothie. And that gives us 10 strawberries altogether. And then 2 smoothies times 10 blueberries per smoothie gives us 20 blueberries altogether for 2 smoothies. Same thing, same method for 3 smoothies. We have 3 smoothies times 5 strawberries per smoothie. We get 15 strawberries altogether. And 3 smoothies times 10 blueberries per smoothie gives us 30 blueberries altogether. Okay, so there's 2 methods. Which one do you think is more efficient? So now we have our information in a table. I'm going to cross this out because I made a typo. Now we have all of our information in a table. If we look at the first column, we have the amount of smoothies, 1, 2, and 3 smoothies. We look at the second column, we have the amount of strawberries based on the amount of smoothies we're making. So 5 for 1 smoothie, 10 for 2 smoothies, 15 for 3 smoothies. Same for blueberries, 10 for 1 smoothie, 20 blueberries for 2 smoothies, 30 blueberries for 3 smoothies. All right, so now we have, just want to move this over here. So what we have done is just found equivalent ratios in our table. We started out with our original ratio of 5 strawberries to 10 blueberries for 1 smoothie, which is a ratio of 5 to 10, as we can see here. And then we multiplied by 2 and 3 to get greater equivalent ratios. So we went from the first to the second smoothie by timesing 2, and we went from the first to the third smoothie by multiplying by 3. And that's how we were able to get our other equivalent ratios of 10 to 20 and 15 to 30. 15 strawberries to 30 blueberries. And that is how many we're going to need to make 3 smoothies. So my question to you is, what does it mean for 2 ratios to be equivalent? Think about it, write it down in your notes. So we have a new vocabulary word, and that is equivalent ratios. What are they? Ratios that have the same relationship as the original reduced ratio. So as we were able to see, all of these ratios for 2 smoothies and 3 smoothies, they have the same relationship between each other. What can we do? What did we do? We multiplied by 2, multiplied by 3. But when we reduced it, each one of them, they all reduced down to 5 to 10. So what can we do to 10 to 20 to get 510? We can divide by 2. And what can we do to 15, the ratio of 15 to 30 to get 5 to 10? We can divide by 3. 15 divided by 3 is 5, 30 divided by 3 is 10, 10 divided by 2 is 5, and 20 divided by 2 is 10. So that is the definition of an equivalent ratio. We also have another definition that you can write down in your notes, ratio table. And that is a collection of equivalent ratios that are organized in a table. So that's pretty self-explanatory. We were able to do that pretty naturally just to organize our thoughts. And it helped us to see what we were working with as far as our ratios, our proportions, and our numbers. Okay, so another question is, how would you find the amount of fruit needed to make 10 smoothies? So we know that we made a total of 3 smoothies. Now we want to make 10 smoothies. What can we do? All right, so we have our table, our ratio table again, and let's remind ourselves what we did to get from 1 to 2 and 1 to 3 smoothies. So to go from 1 to 2, we multiply by 2. Everything in that row. So everything, strawberries and blueberries were multiplied by 2. 5 times 2 is 10. 10 times 2 is 20. And then to go from 1 smoothie to 3 smoothies, we multiply by 3. 5 times 3 is 15. 10 times 3 is 30. So if we're multiplying by a number to get another equivalent ratio, then all we have to do is keep multiplying, right? So we want to have 10 smoothies right here, right? We multiply by 2, multiply by 3. How about we multiply by 10? 1 times 10 is going to give us 10 smoothies. So if we multiply 1 by 10, we have to multiply 5 by 10. 5 by 10 is 50, and then we multiply 10 times 10. 10 times 10, that's 100. Cool. So now we can write our equivalent ratio for 10 smoothies. That would be 50 to 100. And that's our equivalent ratio. All right, so now you know how to use tables to find equivalent ratios. Now you can try some on your own.